Hello everyone. Today's topic is on energy sources. So energy sources means they have the capacity to deliver energy to the other elements present in the network. Again, energy sources they are classified into two types: independent sources and dependent sources. Independent sources means these source that does not depend on voltage or current of any other element present in the network. That means independent source value. It does not depend on voltage or current of any other element present in the network. Whereas dependent sources, of course, its value will be dependent on voltage or current of any other element present in the network. Independent sources again they are classified into two cases. One is ideal case and another one is practical case. This ideal source and another one is practical source. Okay, in ideal we have two cases. Again, ideal voltage source and ideal current source, practical voltage source and practical current source. And in dependent sources, you have four types: voltage controlled voltage source, I'm writing in the short form, voltage controlled current source, current controlled voltage source, and current controlled current source. Now, in this lecture, we'll discuss about ideal voltage source and practical voltage source. Ideal voltage source. So, ideal voltage source, it gives constant voltage across its terminals, irrespective of the current flowing through the terminals. Okay, and ideal voltage source will have zero resistance. So, it is defined as the energy source which gives constant voltage across its terminals, irrespective of the current flowing through, irrespective of the current flowing through. terminals. Symbolic representation of ideal voltage source is represented in DC voltage source, but this is also two terminal element. You take explanation for this is for the upper definition is suppose connect a voltage source across a load. Where let the voltage across this load be VL and let the current be IL. So definition means whatever be the magnitude of current, let the current magnitude be 1 ampere, 2 amperes or 3 amperes. Load voltage is always equal to Vs. There will be current will have no effect on the source voltage. Means that. So to draw the characteristics between load voltage and load current, I'm taking load current on x-axis and voltage on y-axis. Okay. Now when current is zero, okay. So whatever, even if you keep on increasing the value of the current as you move towards the right side of the x-axis, there will be no effect. VL is always equal to Vs. Okay, and internal resistance of I, uh, ideal voltage source is zero. So ideal voltage source does not exist in nature. Uh, Now let's go to practical voltage source. The only difference between practical voltage source and ideal voltage source is practical voltage source will have some finite internal resistance. So it will have some finite internal resistance. Finite internal resistance. So examples of practical voltage source is battery, DC generator, AC generator, all those. So I'm drawing. So this is ideal voltage source normally, and if you place a resistance in series with ideal voltage source, this becomes practical voltage source. Now, with the increase in current, there will be decrease in load voltage. Let the voltage be VL across the load, and current flowing the IL. Now apply Kirchhoff's voltage law here. What do you get? Apply Kirchhoff's voltage law, we get minus Vs less IL into Rs. Voltage across this resistor is nothing but voltage drop. Current flowing to that into its resistance plus VL equals to 0. So we want VL. So VL is equal to Vs minus IL into Rs. So source voltage value is constant, but as you increase load current, drop across the resistance will increase. So automatically your load voltage will decrease. Okay. So I'll draw the characteristics now between load voltage and load current. I, I, okay. When IL is equal to 0, when you substitute here, when IL is equal to 0, VL will be equal to Vs. Okay. But with the increase in the load current, as you keep on increasing the magnitude of load current, this VL will reduce. This is ideal case. Practical case, characteristic will get deviated from its ideal characteristic. So with the increase in current, voltage will drop. This is practical case. Okay. Thank you.